Okay, let's get started. Again, on page 12, we'll take our quick look at the calendar. Last class, we will remind ourselves that we learned something called Hamilton's method as a way to divvy up the seats that we need to give out for the House of Representatives. We figured out how many seats each state should have if everything was perfect, but of course that meant decimal number of seats all around, and we would just take those decimals and round down. And then however many seats we had left over, we would just give them out in order of whoever had the most surplus left over. That was Hamilton's method. Today we tackled two more methods, Jefferson's and Adams' method. Next class, we'll finish learning new methods to apportion stuff, Hamilton, Huntington Hill, and Webster. So a total of 5 methods to give out these seats. And then we will see something about the quota rule and some paradoxes, all right? So that's the next few classes. Officially today, the project on apportionment is assigned. Remember, I'm not giving you anything, I'm not handing you anything, and you're not handing me anything. It's all going to be electronic, hopefully in Excel or some other spreadsheet program. And if you are nervous because it is a computer-based project, start soon rather than starting later, okay? Again, there are lots of good resources on Moodle, specially designed for people that have no experience with Excel, but you got to make sure you give yourself time to look through those resources. Okay. So at the top of page 12, let's go to, I'm going to come down here actually. Why don't we just skip some of the text and just take a look at the chart just to remind ourselves, because it's been a little while since we did this. So we had this country, made-up country called Parador, and Parador had a total of 250 seats to give out. And so here were the populations of each of the 6 states in Parador. And then does anybody remember how we figured out the numbers in the standard quota row? We take the total population, which is 12.5 million, divided by the 250 seats, and it turned out that number was this guy, 50,000. That's right. Each of these, so this 50,000 means every 50,000 people you get 1 seat. And so we would take each of the state's populations, divide by 50,000, and that would give us these. Yes? Okay. So let's fill in the next row, which is the lower quota. Remember, lower quota, we just round everything down. No rounding, just everything goes down. So this 3292 becomes 32. And then somebody with a calculator can check this, but I think it was 246. That's what I remember it being last time. Is that right? Okay, and again, for Hamilton's method, we take the 4 seats that are left over and we give them out based on who's got the highest, I think it was called residue. And so who had the most leftover stuff, just looking at the decimals? A had the most. So A got the first seat that was left over. There are 4 extra seats here. So A got the first one, and then I think we gave D the next one, right? So we just looked at the residues. So this is a different method. What we're going to do instead, I'll give you the whole thing later on. I got to find it. What we're going to do instead is we're going to change the quota. We're going to modify the quota. And we're going to modify the quota in such a way, so here's this number, this 49,500. We're just going to, like, it's just out of a hat right now, that 49,500. But the goal is to change that quota from 50,000 to something else, so that when I actually do my divisions, like 1.6 million divided by the 49,500, and then 6 million divided by 49,500, if I do it just right, then I'm going to get my magic 250 right over here. That's the goal, okay? Want to try to fix it so that everything works out perfectly and we get exactly 250 seats, none left over, nothing more than 250, exactly 250. So thinking about what? Here we go. So this is Jefferson's idea. Let's get a reader. Leah, could you read Jefferson's idea? At the moment, how many surplus seats do we have? 4 left over. We don't want any left over. So what we need to do is make these blue numbers a little bit what? Bigger or smaller? We need them to be a little bit bigger because we don't want anything left over. I want to get exactly 250. Yeah.
Well, we
Good question. Is it possible for the total of these lower quotas to be more than the 250? Right. If we round down, it's got to be less. Right. It's got to be less than the 250, less than how many seats we have. Let's say again, these numbers that are in blue give us 246. I want them to give me 250, which means these numbers in blue are a little bit too small, right? And if I wanted to do some division, I want to take this 1.6 million, and I want to divide it by something so that this guy gets a little bigger, because right now it's too small. Should I be dividing by a bigger number than the 50,000 or a smaller number? It's smaller. If you take something and you divide by something smaller, it makes the whole thing bigger, which is the goal. Just this kind of like opposite direction. I need these numbers to get bigger, so I'm going to divide by something smaller. So this 49,500, even though it's out of a hat, at least it's smaller. It's heading in the right direction. And let's do this division here, and we're going to see the numbers get a little bit bigger. So can we start with the calculators? We're going to take each number and divide it by 49,500. Yeah, Zeke. Right now it's just out of a hat. All we're saying is smaller, and this is going to work perfectly, and then we'll do some where we just have to figure out a number, and there's some trial and error. Yeah, it's like a guess and check thing. Okay, any questions on where these numbers came from? Still, a question you have is where the 49,500 came from. All we knew is that we needed that number to be smaller than 50,000, but at the moment it's just out of a hat. You don't need to add these up. I mean, you'll get some number, but that is not the important number. The important number is what happens when we round these guys all down. We're going to call this next row the modified lower quota. Lower quota is already defined. It's these numbers in blue, but we modified our divisor. 50,000 got modified to 49,500. Yeah, so let's round all these guys down and see what happens. So 33.2 becomes 33. Everybody's getting rounded down. 140, 3, 42, 13, and 19. Okay, and can somebody add all those up for us? I'm hoping it's 250. Is it 250? Fantastic. Okay, so do we see that going from the blue numbers to the black numbers, some of them got bigger? Well, I mean, they all got bigger, actually. Well, some of the blue numbers stayed the same when we went to the black numbers, and some of them got bigger. And that was the goal. We didn't want any leftover seats. So we have no leftover seats. Okay, super. So just taking a look at what happened here. Did this person right here, 32.92, did they get like an extra, or did they sort of stay where they were? They got an extra one because they were going to get 32, but they got 33. That seems fine. We would have given them an extra one anyway the other day. Let's skip past this guy for just a second. This 3.08, seem reasonable that they stayed at 3? Yeah, okay, they're pretty close to 3. That's fine. 4182 ended up with 42. You okay with that? That seems fine. 13.7, 13. That's not so great. I mean, like 13.7 is pretty close to 14, so there's kind of like a question mark about this guy. What about this one here? That seems even worse, right? I mean, they were really close to 20. And this one got 2 extra seats, right? They should have had 138 if we just rounded down. They were pretty big in terms of the remainder, so I'm okay if they get 139. But they got 2, and then we got these other 2 folks that both got shortchanged and didn't get anything. Seems like it's a problem. Doesn't seem fair here. What's that, Tony? They didn't have a 6. Oh, these. I see. So Tony is saying that E and F are both pretty small compared to B, and so maybe it's all right that B. Are you saying it's okay maybe because B has so many more people that maybe it's okay? Yeah. So maybe it's not so terrible just looking at the populations. B is like the most massive state, so maybe it's all right that they got 2 extras. Yeah. Suzanne. E and F got nothing. but using Hamilton, which we did last class, that would have given F20 according to Sue Ann. So F really has a right to complain because if we did Hamilton's, they at least would have gotten their 20. Instead, they got stuck and B got 2 extra, which seems like a problem. Okay, so here is the process. What's the only question we might still have about this process? 49,500, right? Where did it come from? And you know, like, does it always work where you just pick a smaller number and you get exactly the 250 that you want? The answer is no, it doesn't always work. So here's a little flow chart that you can use to kind of help you. You use your standard divisor to get the quotas. That's with the decimals. Then you chop off the decimals because we wanted lower quotas. That's what we've been doing last class and this class. And then we add the lower quotas. What did we get when we added the lower quotas here? Was 246. And that's what we're calling T, so I'll just write this here. In our case, T was 246. Was T exactly the number of seats we had to give out? No. Well, that's too bad. So now we got to follow this top part of our flow chart. And then we ask ourselves, this is the key question. Is T too big or is T too small? 246 compared to the right answer of 250. T was too small, and so it turns out that because T is too small, you want to make the divisor smaller and then start over. What was the original divisor? It was 50,000. What was our new smaller divisor? 49,500. So at least this kind of gives us a sense, okay, if T is too small, pick a smaller divisor. If T is too big, pick a bigger divisor. If eventually T is exactly equal to the number of the seats, then you're done. That's great, okay? So as a general rule of thumb, it's down here in the bottom, how much should you change D by? Well, Caitlin and I, we didn't read this anyplace. We just kind of played with some numbers and thought that this was a handy enough way to start anyway, is that for every seat that you are off from the right answer, maybe you change D by about 0.5%. This is something you might put on a reference sheet as we take test number 2 in a few weeks. Let's just play this game for the example that we did up there. How many seats off were we? 4. It was 4. So 4 seats. And then each one is 0.5% is what we're saying. So 0.5. So this gives me 2% difference. Everybody see that? So then 2% of what? 2% of the 50,000. Let's see, how much is that? 10% would be 5,000, so 2% would be 1,000, something like that. And so if I followed this little rule of thumb, then I would take the 50,000 and subtract off the 1,000, and we get about 49,000. Like, that might be a starting number. I'm not saying it would work. 49,500 worked, but there are a lot of numbers that would work. Like if you change it to like 49,501, it would almost certainly still work, right? The decimals would change just a tiny bit. But this is anyway just a way that you could pull a number out of a hat. Here's a rule we could at least try to follow. Okay, so let's take a look at this. Brendan, can you read 4? Okay, so the populations are there, standard quotas are still there. The next step is to go to our lower quotas. So I'm just going to put over here next step. Is to find the lower quotas, which we've done before, but we'll do again. Lower quota here, 32, so we're just writing in lower quotas. And then we find the total. What was the total? 246. So was that number right there too big or too small? Too small. So I'm just gonna, so this will be in my like next step. T is too small. So we make the divisor bigger or smaller? smaller. If t is too small, make the divisor smaller. If t is too big, make the divisor bigger. So make d smaller. According to our little rule of thumb there, how much smaller might we try? 2%, which turned out to be what number? 1,000. Make it 1,000 smaller, which means you go from the 50,000 that we had to the 49,000. Let's see what happens. All right, now we need some more calculator folks. We're going to take each of these numbers at the top, divide them by 49,000, then we'll come back together in a few moments. Okay, so we had our new modified divisor, 49,000. Notice that the numbers that were in black in the second row, what happened to every single one of these black numbers? Every single one got bigger. That was the goal. Every single one got bigger. See? It should be, even if it's a tiny bit bigger, they should all get a little bit bigger. Then we take a look at our new lower quotas. So we just take each of these guys and chop off the decimal. So this first one drops down to 33, right? 141, 3, 42, 13, and 20. And then we add them up. And this is the part where we got to cross our fingers, because if it didn't work, then we got to do it again. So what do we get when we add these guys up? 252. Well, darn it. It did. I'm just giving you, like, it worked because I gave you one that works. Like when you're working on your homework, it's not going to necessarily work on the first time. Shh. It's not always going to work the first time, right? I gave you 49,500 and it worked. Well, what do you do if it doesn't work? This is t. It's 252. Is 252 too big or too small? It's too big. T is too big. So what is our recourse when t is too big? And make d bigger. If t is too big, you make d bigger. So we had 49,000. We then need to make it bigger. Maybe we'll try halfway, 49,500. We're not going to do it again because it's the same numbers we just did. That one's going to work. But I just got to show you that the process doesn't always happen right the first time. And so you need to be prepared to deal with it if it goes a second or even a third time, right? Any questions on this kind of trial and error process? The important thing to remember, if t is too small, make d smaller. If t is too big, make d bigger. Goes in the same direction. Okay, moving on to number 5. Can we go to Ashley? Okay, so this is actually kind of 3 methods all in one, which is probably what Matt is texting right now. It's 3 methods all in one. So here's the idea. We just learned one method, but it's really 3. The only difference between these next 2 methods and the one we saw is how we round. According to Jefferson's method, everything gets rounded down. Super. Let's take a look at something called Adams' method, one of our former presidents. We're just going to jump in. We're just going to jump in and do an example with numbers. So take a look at the next page. Jefferson's idea was to take your standard quotas and round them all down. Adams' idea is to take your standard quotas and round them all up. So let's take these same numbers that we're very familiar with, and we're going to round them all up. 32 becomes 33. 138 becomes 139. Here's the tricky one. 3.08 becomes 4. It's not the traditional rules of rounding that you know and love. It's round everything up regardless of what's left over on the decimal. Next one becomes 42, 14, 20. And we add them up knowing full well the answer is going to be too big. Right? There's no doubt it's going to be too big. So what do we get when we add these up? 255, is that right? couple folks got 252. Super. So 252. Is that number too big or too small? Too big. So what are we going to do with our divisor? Make it bigger, just like before. It's the same rule. If the thing that you get is too big, you make your divisor bigger. T is big. Make D bigger. Yeah, let's agree on something to do here. So should we try? Should we try something bigger? Like you want to try 500 or 1,000 here? All right, so only 500 worked for us last time. So let's try 500. But I got to get you guys to recognize this is a moment where you have some choice to make. And some choices are going to get you to the right answer in one shot, and some of them is going to take 2 or 3. And I can't help you get there any faster. I don't even have like intuition that I can look at the 500 that's proposed here and say, oh yeah, 500 is going to be great, or it's not going to work. There's a lot of calculations involved. So let's try 500. So what's that? Okay. Yeah, and so maybe the 500 works with the rule of thumb as well. Okay, so are we taking that 50,000 and going up or down? Up. So we're going to try 50,500. Let's give it a shot. So each of the original populations divided by 50,500. Okay, so we take all those numbers. The sum of those things is irrelevant to us. What we really need to do is use the Adams method of rounding, which is to take all those numbers and round which way? Up. That is what Adams says you do every time is you round up. So let's round all these things up. So 32.5 becomes 33 and 138. What about this 3.0? Well, was there a number after the? All right, so then as soon as I see something over there, I say, okay, we're rounding everybody up. So that goes to 4. Doesn't matter how close you are. If you are even the teensiest bit over 3, you get bumped up to the next number. If it was 3 even, then we stay. If it's 3 even, the only way you get rounded up is if you actually have something that got truncated. Yeah, that's the idea. Is that that if we're rounding down, we just, you know what? It might get rounded up. Let me think about it. No, it gets rounded up. Let's come back to Jen's question real quick. Good question. Okay, so what if we had something like this? So it was 3.08, but let's suppose that it worked perfectly and it was just 3. The idea with rounding down is that you can literally just cover up the decimal point with your hand, and that's the answer, right? Doesn't matter what the decimal point is. So if you take 3.000 forever, it's just 3, and you cover up the decimal point, what do you get when you round down? 3. The rounding up answer is always one more than the rounding down answer. So 3 rounded up would go to 4, even though there's no decimal afterward. Thanks for the question. Okay, this 41 becomes 42, 14, and 20. Okay, total. I did not pick this number.
I know I did.
I take no responsibility. But this is what happens, and so we need to recognize how to deal with it on the homework and on the tests. And we played the same game. Is T, this total, too big or too small? T is big, so we make D what? Bigger. So any votes? Oh, we're not listening to you anymore. Who's got it? Want to try go 1,000? So what are we doing? 51,000. Yeah, we were close. Yep. So 51,000. Lots of arithmetic here. You could imagine that having a software database like Excel would take care of all these calculations for us automatically, so it wouldn't be painful to do all this arithmetic. All right, so here we actually got some numbers that worked out perfectly evenly, so we need to use the answer that we got from Jen's question, is that when we round up, literally bump every number up, even if it's perfectly even. So 32.2 becomes 33. That 136 bumped up becomes 137. No, we bump up. We bump it up. Yeah. Yeah. Let's come back to the reason why. Suppose we look at this 3292. Everybody back here for just a second. Look at this 3292. And if I say round up, what part of that number do you not care about at all? The 0.92. You could care less what's over there. So we can cross it off and we can know what we get when we round up, regardless of what's behind the blue, right? What do you get when you round that up? 33. What if I told you now that what I just covered wasn't anything? What would you get when you round up? It's still 33. You don't get to change your mind because all of a sudden you can see what's back there. What's back there makes no difference at all, right? So you cover it up and you bump everything up. So that 136 goes up to 137. This 3.01, just barely, but it goes up to 4. This guy bumps up to 42. This one, that's, yeah, 14 there and 20 there. What do we get? Hooray, 250. So admittedly, it's not the most fun process to do, but with a little bit of practice, you can kind of churn through these calculations relatively quickly. I will tell you on the test, which is still a ways away, there's going to be a question about Adam's method, and it's going to say, like do the whole process. So how can I make it so you don't spend like half an hour like fiddling with this divisor until you get one that works? So on the test, it's going to have something like this. You're gonna like this. It's going to say, okay, you do your basic standard quota thing here, and then it's going to say one of these two modified divisors, and I'm going to give you two different numbers. Like I'm going to give you 50,500, and I'm going to give you 49,000. I'm going to say one of these two numbers is a possibility. One of these two numbers is at least headed in the right direction. For Adam's method, which one is the one that heads in the right direction? Is the one that's bigger. And so it's just going to say pick the one of these two that's bigger. And oh, by the way, if you choose the one that works, if you choose the right answer here, that's going to be a divisor that works for you in the table. Right? So you're not going to have to do this table row after row after row. I'm going to give you this gift of, hey, one of these two numbers works, just have to pick the right one. All right? Jen? I'm going to tell you, if you choose, as long as you go the right direction up or down from the 50,000, the basic one, the number that I give you will work. Okay. All right. That's right. Totaling the modified numbers don't give us any info. It's really the rounded ones that we care about. Okay, so is there a problem here? Let's see. This person right here ended up like in the final tally with 33. Does that seem okay, or is that seems fine, right? How about this 138.72? Isn't that troubling, right? Hamilton will never let anybody lose. They're just going to bump some people up, but not every person up. But look, state B, this is Tony's favorite state. They're the biggest state by far. Not only did they not get their like 138, like that seems like bare minimum, and they maybe should just get rounded up because they're so close to 139. They didn't even get 138. They ended up getting 137, which just doesn't seem fair. This guy went up, this guy went up, this guy went up, this guy went up. So it seems like everybody went up except for poor state B here. Yeah. And it turns out that Adam's method favors the smaller states. You're seeing it here. All the small states here benefited, but the big state, state B, ended up kind of getting shafted a little bit. And it turns out that Jefferson's method favors on the other side. And so, like if you're a big state and you're trying to figure out which one of these is going to benefit you, you have a vested interest in choosing Jefferson's method, right? And the small states would rather have Adams' method. And so these problems arose, and Jefferson and Adams, they didn't understand that they didn't intend to try to make something that always favors the little guy or always favors the big guy, but it was just a consequence of the way they chose to do things. And so this was really like a messy situation for a long time. So here's a mnemonic, little typo in the word mnemonic, to remember the methods so far. So we have Hamilton's, Jefferson's, and Adams. Let's jump to Jefferson's and Adams. In Adams' method, which way do we round? That's the one we just did, is up. And you could imagine the A is like an arrow pointing up. There? What did we do for Jefferson's? Rounded down, and if you kind of draw your J like a little bit pointy, and it's an arrow pointing down. Okay, so far so good. Hamilton's method, so I didn't make this mnemonic up. There's always extra ham to give out, so you give to the extra. That was the one with the extra, like whoever had the most extra would get another seat. Now, I'm an ethical vegan, so I'm not going to support the use of this mnemonic device, but until I come up with something better to share, I guess this is what you have as a possibility. So here's what you're going to do. The class activity is to take this new problem. I don't think you've seen these particular numbers before. What is the first method you're going to use? Hamilton. Then you're going to go to the next page, and then you're going to do the same numbers but Jefferson's, and then you're going to do the same numbers but Adams.